Basic purpose of a solar box cooker is to heat things up. A solar box cooks because the interior of the box is heated by the energy of the sun. Sunlight enters the solar box through the plastic top. It turns into heat energy when the dark paper on the bottom absorbs it.
The newspaper provides insulation which traps the heat inside the box, allowing it to cook the item more efficiently. This heat input causes the temperature inside of the solar box cooker to rise until the heat loss of the cooker is equal to the solar heat gain.
The design of our project was simple. We used a box that is similar to a pizza box and cut along 3 sides on the top of the box, which allowed for us to create the flap that we then wrapped around in aluminum foil. Then we covered the hole in the box with plastic wrap, and at the bottom of the box we put dark construction paper, and then around the rims of the bottom of the box there's newspaper to provide for insulation.
Heat is lost in 3 ways: conduction, radiation, and convection.
Conduction is because heat within a solar box is lost when it travels through the molecules of tinfoil, plastic, cardboard, air, and insulation to the air outside of the box. Radiation is because most of the radiant heat is given off by the dark paper within a solar box that's reflected from the tinfoil and back to the plastic to the dark paper. And convection is because the heated air molecules within a solar box escape, primarily through the cracks around the top lid, a side opening, or just any construction imperfections. So cooler air from outside the box also will enter through these openings, allowing for heat loss.
Our product meets the definition of green energy because it's solar energy.
And solar energy is natural and renewable.
The efficiency of our solar box cooker can be described by this picture. So the equation we used would be heat out divided by heat in. And so the heat in is from the sun, and the sun provides 1,361 watts per square meter of energy, and you multiply that by the amount of time we left our chocolate to melt, which was 420 seconds, which is then multiplied by the area in which the chocolate was that it was melting in, which would just be the solar box cooker itself. And then that totaling equals 37,155. And then the heat out would be the chocolate. And so the formula we use for that is Q equals MC delta T. And the mass of the chocolate itself was 37 grams, which we then multiplied by the specific heat of chocolate, which is 1.6, which was then multiplied by the change in temperatures, which equaled 26 degrees Celsius. And so that all multiplied together is 1,539. And once you divide 1,539 by 37,155, you get approximately a 4% efficiency. And a way to make our project more efficient would be to eliminate the amount of heat loss through different ways that we described earlier, whether it's through cracks in our project or construction imperfections. And then also, if we would increase the size of the box, it would allow more sun to reach the box, which would then be able to be reflected in the box among the chocolate, which would help it melt faster and more efficiently. Here's a picture of the chocolate after it had been left out in the sun for 426 seconds and was melted through our solar box cooker.